Okay, so the line equation of intersecting line without using GC is quite straightforward, right? To use without using GC, I think what... Okay, so for L4, mid L4, so you have to know how to do it without using GC, super important. So line of intersection. Okay, so just like any of the previous part, we are already threading into the relationship between two planes. That's the last relationship you can ever have already. So between two planes, you must be able to find if they are parallel, what is the shortest distance between them. If they're non-parallel, what is the line of intersection, and then what is the angle between them. So if they are parallel planes, the other one which like to come out is this second part. This a few units away one. Okay, so later we talk about that. So let's look at line of intersection. With GC lah. I think the first one is using GC is easier. So method 1 is using GC. Using GC will mean P1 Cartesian format x minus 3y plus 2z is equals to minus 5. P2 2x minus y plus 3z equals to 1. Okay, using GC, just keep both of this in, and the GC will tell you what is it. So just key in, go to apps, count it. Go to app, then you go to simultaneous equation solver, number 9. Is yours 9 also? Oh, interesting. So simultaneous equation solver. You have 2 equations, 3 unknowns. Make sure that's it. Then you go next. Then this is the clear it by pressing the zoom button. The clear button corresponds to the zoom. Then you just key in. Okay, so I think this is pretty straightforward. 1, -3, 2, -5, 2, -1, 3, 1. Okay, solve it. You get this thing here. Remember, this side is XYZ. Okay, this guy here is your lambda, lambda, lambda. So you see this as x is equals to 8/5 minus 7/5 lambda. Y equals to 11/5 plus 1/5 lambda. Z equals to 0 plus lambda. Okay, your calculator always try their best to let Z equals to 0 plus lambda. So once this is done, so it should be fine. You know that this R L4 8/5 11/5 0 plus lambda -7/5 1/5 1. Obviously the 5 we can multiply by 5 here because the 5 can be absorbed to the lambda, so we are okay. This case here, L4 okay, here you go. L4 done. Now what I want you to understand is this. If this is L4 and this is P1, this one you need to know, this is P2. Okay, then we know that the direction of 1 is here. Then this is normal 1. The other guy here is normal 2. Then what is direction of 4? Correct, cross number 1 and cross number 2. So you have to visualize it like that. So if you have, you can see this. If you have 2 planes like that, plane 1 and plane 2, right? To get this direction, the normal should be this normal and this normal. You cross them. Fleming don't know left or right hand rule. I think Fleming's hand has been amputated by how many times already. So essentially, it's right. I don't know. I really don't know which cross product, but essentially, you take this. I don't know if you can see here and here. You cross it, you get a direction perpendicular to both. Okay, so you have to know that because some of the question will ask some. Okay, so the direction is in the summary notes lah. So this is it. Here. So if you look at this here, the direction of the line, this is under the vectors, the last page. The direction of the intersecting line, the direction here is N1 cross N2. Okay, cross them. But more so visualize it, like understand it before you memorize it. Don't just visualize it. Then once you understand it, then it's okay. So we just do some recap. So this direction D4, we know is definitely parallel to N1 cross N2 N1 cross N2, right? So you just cross them. Cross them. Then this one, am I right? This one correct. Then you just cross them. 4, done. Okay, great. Done deal. The direction done already. Now, how do I... Okay, so last lesson, we talked about any XYZ satisfying the plane equation will be on the plane. So, for example, I know that -1, 0, -2 will be on the plane. 1. Remember that? Any combination of... Okay, I'll just explain. Any combination of X, Y, Z satisfying plane 1 would be on the plane. So, for example, P1 is X minus 3Y plus 2Z equals to -5, right? I know the point for sure, -5, 0, 0, easy game. This one will be on the plane 1. Agree? If plane 1 is X minus 3Y, because you substitute this in, it gives you -5, ma. What else I can put? I can put 0, 1, -1. Alright. 0, 1, -1, then it will be -5, ma. -5, yeah, that's why I said -5, 0, 0. But the thing is, now you have another plane here. You need to find another point satisfying both planes. What do you do? That is the question. So you can either... Yeah, I repeat, you want to find X, Y, Z which satisfy both plane equation, right? But we have the luxury of choosing now because plane 1 and plane 2 have infinitely many planes. So I can let anything, like say today, you happy, you like the number 9012. You can let X be 9012 and then solve for Y and Z simultaneously. Understand? I repeat, you can pick any number. So the easiest way is letting X equals to 0. Let X be 0, this will be this equation, right? You just want to find 3 points satisfying these two planes equation. So you just pick X equals to 0. So when I let X be 0, this will be this. Then I just solve this simultaneously. This will be from GC. This will be Y equals to 17 over 7. And then 8. Z equals to 8 over 7. So I know for sure 0, 17 over 7, and 8 over 7 will be on both P1 and P2. Understand? That's how you form. That's how you find a point between the two planes. Because finding the line equation, you need a direction and a point. So the point here is 0, 17 over 7, and 8 over 7. So this is one possible point. It doesn't matter. The answer, I let Y be 0. Okay? You want to let x be 0, this is your answer. So this will be so without using GC. Okay, so this will be okay. Same. Sorry. That's that. Okay, so is that the answer? Yeah. Yeah, right. Correct. Thank you.